Good day, everyone, and welcome to this 3D virtual tour of Symphony assembly technology. I'm very pleased to be able to be with you this afternoon and to walk you through this tour, giving you perhaps the next best thing to actually being present and seeing this technology in person. So let's, without further ado, plunge right in, and I guess I'll start by kind of orienting you to what you are seeing here. This is, in fact, a Symphony assembly cell constructed of multiple modules, as we'll discuss here momentarily. And it's located in our Innovation Center at ATS in Cambridge, Ontario. As you can see, the cell itself is in the Innovation Center, where we're also featuring other examples of innovative ATS technologies. But our focus today is going to be on Symphony. Symphony is interesting assembly technology from a number of perspectives. It is designed for high-speed operation. We'll see examples of that as we go through. It's also designed to be very flexible. It has a very high level of standardization, which means the amount of project-specific touch tooling is quite minimal. And it's modular in construction, so it can be used to, can be configured and reconfigured as necessary to meet changing production needs, or maybe the complete reconfiguration of the system from one product to another over the course of time. So we'll start here with being, as you can see, we're kind of in front of the machine here. I'll just make a few points here just to kind of illustrate some key characteristics from a physical perspective. Number one, again, as Andy said in the lead up, and as I just reiterated, the technology is modular in nature, and we can see evidence of this in this view, where we've got basically two working modules on this side. There are two similar working modules on the other side of the line that we'll eventually get over and see. And then there's also two end modules, or what we sometimes refer to as end caps, kind of bookending the system, so to speak, where on one end we have an end cap that serves to receive main power distribution, handles all of that distribution of power and air through the system. And then the other end cap is used to house the PLCs and associated electronics for controlling the SuperTrack pallet transfer system, which is at the basis of the Symphony technology. But then otherwise, each individual module that you'll see, or what we call working modules, is a self-contained plug-and-play unit, so to speak. The width of a module is 1 meter wide, so this distance here is roughly 1 meters. That corresponds as well to the standard 1 meter section width of SuperTrack conveyance, and in fact that's the reason why the 1 meter width was chosen for the Symphony module design, was to have that inherent alignment and compatibility with the SuperTrack section. And as you can see, the the modules are very highly standardized. We'll see this more as we get into this, but within each module, the modules are actually controlled. Like I said, they're self-contained, so they're controlled by controls that are resident, and electrical controls and hardware that are resident in the control cabinet that mounts above or sits above each individual module. So literally each module is a self-contained unit. Everything that is needed to move and control whatever automated tooling that we have within that module is basically under the local control of the electronics that are there. So without further ado, let me just kind of zoom in a little bit here so that you can get a better picture of what we're talking about with the Symphony system. So you'll notice, first of all, again, that in the center of the system we have Symphony is a palletized assembly technology, a palletized platform. And the pallet system that we use is the ATS SuperTrack, which is a long-running ATS product, essentially linear motion conveying system. That is, pallets are transported by electromagnetic energy. with giving them a very high degree of speed, acceleration, control of speed and acceleration, and of course positional accuracy, with the ability to stop pallets at any point along the track without need for external lift and locate mechanisms or things like that. So a tremendous amount of flexibility and capability built into the conveying system itself, moving these pallets around from station to station. The next thing you'll notice is that hanging from the ceiling are a series of very similar, in fact, from a base perspective, they're identical pick-and-place robots. These are specially designed robots that part of the Symphoni platform. They've been optimized to perform the task that they're designed to perform, which is essentially to pick up parts from these discs, which we call RSM discs. I'll explain those in a little bit more detail later. And to these discs, which are receiving parts typically from upstream feed systems. In this demo cell, you'll notice we don't have feed systems being part of this. Basically, what we're doing with this particular configuration is we're just assembling and disassembling a two-piece product that we've designed just for demo purposes. So basically, what that means is this happens to be the final unload of the product, where that unloaded product gets then shifted down to the disk at the load station to restart the cycle. Again, we'll see that evidence of that in more detail here as we go forward. But the bottom line is that we have a high level of standardization in the module, in the sense that you will see the RSM disk, you will see the standard Delta robot, which has been configured, as I mentioned, to operate with optimum efficiency in moving parts from the disk to the pallets, and to do that at very high speeds. With a very minimal amount of touch tooling, which is configurable, and as we go into the inside of the machine, you'll see examples of different types of end-of-arm decks, as we call them, with end-of-arm touch tooling mounted to them. So let's take a little step inside the machine, going a little bit more deeply. I guess before we go any further, I'll just play a quick video for you so you can see an example of what SuperTrack looks like in operation, or a Symphoni system. This isn't the demo system that we're walking through. This happens to be a separate production system during its while it was being readied for factory acceptance test at ATS. So you'll see here initially, as you saw, the pallets are moving slowly through the system, and then we're able to ramp the system up to operate at its designed rate. And you see, we'll let that run one more time. You see that again, the pallets themselves moving through the system with by electromagnetic force. You'll see them positioning at stopping at various positions depending on the operations that are required. You see quick accelerations and decelerations and presentation at individual stations, which is perfectly timed to coincide with that station's required operation. So again, just continuing our tour here, taking a little, maybe a little bit more in-depth look at what constitutes a pick-and-place station. So this happens to be, one of the pick-and-place stations in this particular configuration. It's the first station in the system. Zoom out a little bit here so we can see more what's going on. So I mentioned before, this station is going to be receiving a part that has been released from this station that's upstream, bringing a part in to the disk. You'll see as I play a video here momentarily that the part gets captured. This camera then, the disk is on a rotary servo, so the disk is rotated progressively around until such that each part is presented to this camera. The camera takes a picture of the part, determining what radial orientation the part has to be in, because one of the characteristics of Symphoni is it can do both high-speed pick and placing and radial orientation at the same time. So we capture parts into the disk, we check their orientation with a camera. The robot will then pick up, in this case, 2 parts at a time. You'll notice when I play the video that the end effectors are also equipped with rotary servos so that we can correct the orientation and place them into the correct orientation on the pallet. So let's just take a look at what that operation looks like. There we see. So parts coming in from the upstream station. In this case, just a very simple part that nevertheless, because of the circular nature of the disk and there needs to be an orientation correction between the disk in order to place it properly onto the pallet, and that's what those rotary end effectors are doing. The videos that you'll see in this system are all taken of the machine operating at 280 parts per minute. Which, again, think about that for a moment. This is a palletized transfer system. We're operating 2-up, and effectively we are stroking at a 140 parts per minute, or 140 strokes per minute, loading the parts onto the pallet. So again, one of the characteristics of Symphoni is its high-speed capability. We get the high speed, as you can kind of see repeatedly in this video, from the fact that as the pallet is arriving in the station, we're already, the pick and place robot already has the parts and is moving the parts towards the pallet such that we're able to keep the amount of time that the pallet is in the station to an absolute minimum and therefore get the high throughput. So continuing on, we'll go into the inner portion of the machine, and you can kind of see how, from a perspective view here of, basically from the center of the super track, what other stations look like, how they're configured. So you see in all cases we have the robots, we have the RSM disk, we have different types of end effector tooling depending on the requirements of the particular operation. The pallets, which of course, as you saw in the video, which are circulating in this case in a clockwise fashion. So we're at this station here, and we saw that part being loaded. The next operation in the demo system basically takes place over here on the other side of the system. So we've loaded the white part that you noticed in the video. Second operation then is to place this black part that goes on top of it. So again, 2-up load, again, backside of the line, same sort of thing as we saw before, pick and place stroking between the RSM disk and the pallet. Pallet spending next to no time at all in the station, allowing a very rapid throughput. So you might as well just complete the tour here, and we'll go down to this end, maybe turn around and take a look from this particular perspective to see the couple of the remaining stations in operation. Let this one play. This is a station that's actually doing an unloading operation. So in this case, the part is being, the white part is being removed, placed back to the disk, which is, you've seen before, that disk basically has its is configured such that it then delivers the part downstream to the load station, so the cycle can be started again. Some other things that I can point out here. You'll notice here there's an indicator light. We won't see it, I don't believe, in this view, but we should see it here in another view that I'll go to shortly. But these indicator lights are basically, they serve an interesting function here. It's obviously possible with Symphoni, if there's an issue that occurs, the machine gets shut down, it's possible for operators or technicians to come into the system, move tools around, that is, move the robots in different positions, move pallets around, things of that nature. When we want to restart the machine then, because of the possibility of this manual intervention, it could be the case that things are not put into good starting positions to allow the machine to start back up. And that's what these indicator lights, you'll see indicator lights again here. This one corresponds to the palette. Each individual robot has a similar indicator light on it. This light will change colors depending on whether or not, in this case, this light, whether or not pallets are in a position safe to restart the machine. If they are not in a position that is safe to restart the machine, the light will be red. What's the correction for that? Well, the correction for that is basically for a technician to come in and basically move any pallet that is maybe out of position into a position that permits the light to, or permits the station to restart safely. In which case, the light turns green, and the operator knows, okay, everything is positioned well, I can start up. Now, that does not necessarily mean that parts have to be precisely positioned at particular locations. It just means that in the case of pallets, the pallets have to be in areas that are permissible. Those tend to be pretty broad areas, so pretty easy to get things configured for startup. Likewise, the robots have to be in positions where when we start up, there's not going to be a sudden movement that would cause a crash in tooling or what have you. System automatically detects this and gives an indication of whether we're in a safe state or not, and allows us to start or not accordingly. So maybe just point out a couple of things about the robots. Again, kind of a historical note. In developing the technology originally, the idea was not to custom design a robot, but to rather use off-the-shelf robots. But again, the goal has always been, or was always, to make a very high-speed platform capable of doing significant work. So when in investigating off-the-shelf Delta robots, for example, quickly became clear that they neither had the required speed nor the required strength to do the operations that were required. So it led to the development of this Symphoni robot, which again is designed for essentially for moving parts from the output of a disk to a pallet. So a very short stroke rate, but with the strength and the strength necessary to exert significant forces for high force operations, as well as to have through finite element analysis, having the linkages designed for a minimal amount of weight, so that we can move at the high speeds that we want. So and what do we mean by high speeds? Basically, these robots are designed to stroke at up to 200 per minute. We usually don't run them that fast. Usually we limit the stroke rate to 150 cycles per minute, which means that if we're operating 2 up, that gives a nominal output through a station of 300 parts per minute. If we go 4 up, 600 parts per minute, etc. So again, digitally controlled technology, palletized technology, modular technology that can achieve the same types of throughputs as more traditional hard automation that's common for those rates, such as continuous motion machines. So I think we've done a pretty good general introduction of what's going on in this machine. Oh, I do want to show you one important thing to see if I can get over to an area where we can see the HMI. Here we are. So here's the HMI of the system. Typically we have by default one HMI, but we can put more than one and mount them at different corners of the machine. If particularly for large installations, that can be beneficial. But in most cases, we just have one HMI. And you can do a lot of very interesting things from the HMI. Basically, from a software perspective, you have a very, very high level of standardization from one station to the next. The core software that handles all of the high-speed motion, that minimizes the non-value-added time, coordinating the motion between pallets and robots and disk. All of that is controlled through electronic camming. And that is basically part of the firmware of the system. So that's not something that requires detailed programming. It's standard. It works. It's been deployed for years in operations with this technology. So basically, that's black boxed out as sort of just embedded firmware that you don't have to worry about. But through the HMI, you can do things such as select different types of profiles, adjust pick and place points. Should that be required, you can make adjustments in pallet positions and 0.01 millimeter increments, etc. Another thing that you can do from the HMI is you can select what rate that you want to run at. One of the characteristics of Symphoni is that it operates in a synchronous fashion. So even though it is digital, even though it is highly flexible, when it operates as a system, it operates such that all motions in the system are completely coordinated as if they were all mechanically geared together. In fact, they are geared together. It just so happens that they are electronically geared together. And that allows us to do some interesting things like what I'm going to show in the video here. And that is we can go up to the HMI. For example, if we've got our machine running at 25 parts per minute, and we want to change that rate to, in this case, what it was designed to run to, 280 parts per minute, literally it's a touch of a few fingers, and we can toggle back to 25. Now, what's significant about this is, again, it indicates that even though each individual module is locally controlled, the modules are linked together, and the motions of those modules are electronically cammed together to operate as a system. Just go back and let us see that again. So, you know, regardless of what rate the machine is running, all of the motions are coordinated together in the same fashion. So again, this can be a very useful and helpful thing if you've got something going on in the machine and you want to, that maybe an intermittent issue that's occurring and you can't really see what's going on with normal high-speed operation. You can go over to the HMI. You can reduce it down to half speed, a quarter speed. You can take it down to 1 part per minute and actually get in and see what's going on and use that as a troubleshooting aid. So I'm going to go back in the machine here and just take a quick look at a couple of other machines that we've also got tours for. We'll just do a quick look at a medical device machine that you know, again, we took this video. This is not a demo. This is an actual production machine, so you can see, you know, what a production machine looks like when we've got feed systems delivering parts into the RSM disk. In this case, you know, our pallets are I believe 4-up operation rather than the 2-up of the demo. But again, you'll notice that the same type of construction, same modules, same types of robots. It just so happens that you know, from this point down, the end of arm tooling differs for this robot than what it is over here. But everything else, very, very high level of standardization. Exit this and go back to, well, we'll take a look at a slightly larger machine. Again, similar type of application, but again, because of the modularity of the system, you know, we are able to configure systems, you know, for whatever size and length or whatever size number of operations required for the given application. In this particular case, this, I believe, was had 6 operating modules, whereas the previous one had just 4. But a similar type of product assembly, medical device assembly, is what we just saw. And in fact, we can do just a quick case study, if you will, of one of those 2 systems in operation. Here we see, looks like this is the 6-module system in operation. So again, our SuperTrack pallets flowing through the system, RSM disk delivering parts, In this case, there happens to be a seal being loaded that requires a little bit of expansion of the seal before it's placed on the fixture. Assembly operations. In this case, I think it's a 4-piece assembly that we're doing. And if I'm not mistaken, I think we're at 300 parts per minute here. So, all right. So let's go back to the virtual tour here. We'll escape out of the tour, or out of the middle of the machine, if you will. Get ourselves back to where we can see the machine in kind of a perspective view here. Let me get ourselves reoriented around here, back to where we were at the beginning. So at this point, basically I've accomplished what I was intended to do with you in terms of at least giving you an initial overview and perspective of the technology. Again, it's not quite the same as being a true hands-on view, but hopefully this gave you a little bit of an overview. I do have another slide. We'll switch back to 𝗪𝗧𝗛𝗡𝗘𝗖𝗧 control here momentarily, because what we've seen so far in the system is we've seen evidence of how it's constructed, how it operates, the fact that it can do high-speed assembly operations. But what is also equally important to recognize is that the control that Symphoni offers with the digital control, servo control, gives us the ability to do very complex operations and to control those operations, really study and analyze those operations to make sure that we are giving all of the time necessary to the process while still eliminating any non-value added time that we possibly can to maximize throughput. So I've got a slide to walk you through with some additional videos that will indicate that. But for now, we'll leave the tour. We'll go back to 𝗪𝗧𝗛𝗡𝗧. This tour, as I understand it, will be made available to you to review at your own leisure. And certainly, if there's questions either now here at this webinar or afterwards about the technology or how Symphoni operates, if you're interested in taking a deeper dive into some of the more technical details, as this was a very high-level introduction, we can certainly explore that with you. So thank you very much. Turn it back to 𝗪𝗧𝗛𝗡𝗖𝗧. She'll put up the slide that I was referencing. We'll talk through that briefly, and then we'll be ready for questions and answers. So thank you very much.